The mode, median, and mean are all measures which give an idea of the size of the numbers in a set of data. Suppose that there are two apple trees. The mean size of the apples on the first tree is 9 centimetres. The mean size of the apples on the second tree is 7.3 centimetres. This indicates that typically the first tree produces larger apples than the second tree.
The range of a set of data gives us an indication of how spread out the data is. A large range tells us that the values are more spread out. A small range tells us that they are closer together. Suppose we are in a cafe with a baby, some teenagers, some middle-aged women, and a man who is 70. The range of ages will be about 70, depending on the age of the baby. The age range in a Year 11 class will probably be 1 year, 16 subtract 15. The age range in the cafe is much bigger than that in the Year 11 class. That's because there is much more age variation in the cafe.
Coming back to the apple tree example, on the first tree, the mean was 9 centimetres. Let's say now that the size range is 3.4 centimetres. The second tree had apples with a mean size of 7.3 centimetres. Now let's suppose that the range of the sizes of these apples is 0.9 centimetres. The apples from the first tree are generally larger, but there is more variation in their sizes. The apples from the second tree are typically smaller, but they are more consistent in size.
The interquartile range also gives us an idea about the variation in size within the data. Because the interquartile range works only with the central 50% of data, it ignores any unusually large or small values, otherwise known as outliers.
It's possible to approximate the median and interquartile range of a set of data using a cumulative frequency diagram. Start by halving the total frequency. This will give you the position of the median value. Using this set of data, the 16th piece of data will be the median. Reading off the curve indicates that the median length is 30 centimetres. To estimate the lower quartile, find 1/4 of the total frequency, that's 8, and find the length value that corresponds with the 8 on the frequency axis. This gives a lower quartile value of 28 centimetres. To read off the upper quartile, we need to find the value that is 3/4 of the total frequency. That's 24 on this graph. Next, we must read off the length which corresponds with a cumulative frequency of 24. It's 33 centimetres. The interquartile range is the difference between the lower quartile and the upper quartile. That's 33 minus 28, which is 5 centimetres.